Hi everyone, this is Miss Graham, and today I'm going to be going over lesson 11.1, congruent triangles. Make sure you pull out unit 2 of your textbook. Unit 2. We are going to be looking at transformations, triangles, and quadrilaterals in this unit. So we are going to be starting off on page 143 and going through page 146. Let's look at our learning targets for today. Today, we're going to use the fact that congruent triangles have congruent corresponding parts. And we're also going to determine unknown angle measures or side lengths in congruent triangles. Most importantly, we're also going to learn what the word congruent means, since we know that it's a part of both of these learning targets. So let's go ahead and look at the situation that we have below. It says Greg Carpenter works for the Green Construction Company. The company is building a new recreation hall, and the roof of the hall will be supported by triangular trusses, like the ones shown below. Off to the side, it says triangles are often used in construction for roof and floor trusses because of their strength and rigidity. Each angle of the triangle is held solidly in place by its opposite side. That means the angles will not change when pressure is applied, unlike other shapes. Overall, they're saying that triangular trusses are built because they are more durable, more firm, they are more rigid. When they're being built, it looks like it's going to have more of a solid foundation. It says each of the trusses contains pairs of congruent triangles. So Greg's boss tells him that his first job will be to determine the side lengths and angle measures in the triangles that make up one of the trusses above. So it goes through, what we're looking at in this real life situation, but we still have to understand, what does congruent mean? So over in the margin on the right side, it starts to go over what congruent triangles are. It says congruent triangles are triangles that have the same shape and size. So it might be good for you to highlight or put a star by this, because this is something we're going to continually to see over this next unit, the word congruent. Here, more precisely, we've seen that if two triangles are congruent, if and only if, one can be obtained from the other by a sequence of rigid motions. So what we're saying is, if we do a translation, a rotation, if we do a reflection, we are going to come up with two triangles, the pre-image and the image. Both of those are congruent because they are the same size and shape. Let's go ahead and turn to the next page so we can start applying this idea of congruent triangles. Here, Greg wonders, if I know that two triangles are congruent, and I know the side lengths and angle measures in one triangle, do I have to measure all the sides and angles in another triangle? Greg begins by examining two triangles from the truss. According to the manufacturer, these two triangles are congruent. So below on question number 1, it says, because the two triangles are congruent, because we know that, can one triangle be mapped onto the other? If yes, what are the criteria for mapping? So starting to look at this, think about this. We know if the two triangles are congruent, they are going to be the same size and same shape. So that means, yes, we know that each triangle can be mapped onto the other. Now we have to say, maybe through a sequence of rigid motions, how we can do this. Let's go ahead and answer the question first. So we know, yes, each triangle can be mapped onto the other triangle since they are the same size and shape. Remember, that's what the word congruent means, so I'm putting that in parentheses. And we're going to say we can do this. We can do this through a series of, and I'm running out a little bit of space, I'll put rigid motions kind of down here. So let's actually figure out what type of rigid motion we could look at. So I want you to pause the video here. Think about, can we do translations, rotations, or reflections? Do we need to do a couple of these? What do you think we need to do? So here's what I was thinking. There's two ways that we could go about this. Let's say I wanted to draw a line of reflection right here where the letter F, or really point F, is on the line of reflection. I could say I could move triangle ABC to the right so that point C is on point F. And then I could use the line of reflection and reflect triangle ABC over the line of reflection, or over, the line point F is on. So that way A would map onto D, B would map onto E, and C would map onto F. So that could be, two different transformations we're using. Something else that I was actually thinking of was, what if I drew a line of reflection, and I'm just going to label it line of reflection. What if I drew a line of reflection the exact same distance between points C and F? And then I reflected triangle ABC over the line of reflection so that A mapped onto D, B mapped onto E, and C mapped onto F. That could be exactly what we're doing. So I'll say one example over here of what we could do to map one triangle onto the other is we could do a reflection over the line of reflection, and I'm just going to put in parentheses that we drew the line of reflection. Now we don't know which is our pre-image or image, so I'm not going to say, ABC to, DEF or vice versa. We just know that it's going to be some type of reflection. So that's another possible idea of a rigid motion that we could do. Let's go ahead and start looking at number 2 below. So number 2 says, suppose you use a sequence of rigid motions, right, just as we talked about to map triangle ABC to triangle DEF. We talked about a series of them. We did the first one, which would be 2. The second one, we talked about only one type of rigid motion. So just keeping that in mind, we could have a sequence of them. So now it wants us to find the image of each of the following under this sequence of transformations. So remember what we talked about. This arrow means corresponds to. We are trying to figure out which line segments correspond to each other, or we're trying to figure out which angles correspond to each other. So go ahead and pause the video right here. I want you to see if you can fill in the correct information. Remember, order does matter here. All right, go ahead and check your work with mine, making sure you labeled appropriately where we need to put line segments as well as angles. I kind of gave you a little bit of help before when we were going through it, but just make sure each of the ones corresponds to the other correctly. Let's go ahead and look at number 3, still building off of the problem we kind of have above up there. So it says, what is the relationship between line segment AB and line segment DE? It then asks, what is the relationship between angle B and angle E? It also asks, how do we know of this? So let's think about this, all right? If we know that one segment corresponds to the other, right? We know AB, we know it corresponds to DE. Something else that we also know is that they are going to be congruent. So I should put the congruent symbol. That means it's the same size, same shape. So same thing with angle B to angle E. Yes, we know they correspond, they match to each other, but something else we know is that they are going to be congruent. They are going to be the same size and same shape. Now, our reason for this is because there is a sequence of rigid motions, or there's at least one rigid motion where we can map AB onto DE and we can map B onto E. So that's what we're going to say. We're going to say those are congruent because there is a sequence of rigid motions that maps AE to DE and angle B to angle E. All right, now that we have that understanding down, let's go ahead and look at the part below. It says the triangles from the truss that Greg examined illustrate an important point about congruent triangles. In congruent triangles, corresponding pairs of sides are congruent, just as we saw above, and corresponding pairs of angles are congruent, as what we also saw above. These are corresponding parts. So what I'm going to do is I'm going to highlight that word. And I know on the margin it kind of tells us, okay, what that really means. So let's go ahead and read that as well. It says corresponding parts result from a one-to-one matching of sides and angles from one figure to another, just like what we did above. Congruent triangles have 3 pairs of congruent sides and 3 pairs of congruent angles, which makes sense, right? Triangles have 3 angles and 3 sides. When we write a congruent statement like triangle ABC is congruent to triangle DEF, you write the vertices so that the corresponding parts are in the same order. So you can conclude from the statement that AB is congruent to DE, just like what we said above. But we can also look back at our picture, right? And we can also say BC is congruent to EF, right? What we said before. AC is congruent to DF, and we can also do it with the angles. Angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. On to the next page, it starts to look at example A, focusing on congruent triangles. So in example A, it says for the truss shown below, Greg knows that triangle JKL is congruent to triangle MNP. So for me, sometimes I like to outline the triangles so that way I know which ones I'm specifically looking at. So I have that triangle and then I have this triangle as well. So Greg wants to know if there are any additional lengths or angle measures that he can determine. So just thinking about this, we're given, and I'm going to be a little bit more specific. We're given, it looks like, oops, sorry, let me try that again. We're given one side length here. We know, KL is 2.1 meters. So if we know KL is 2.1 meters, we would probably want to match it to whatever the other side is. Now, be careful when we're looking at that other triangle. The order in which we're given the letters here is going to correspond with the letters here. So we know J is going to match up to M. We know that K is going to match up to N, and we know L is going to match up to P. So looking at which side length of our second triangle, that black triangle, would match up to KL, well, we can see it would be NP. So that's why below here we're going to say KL. Let me try that again. We're going to say that KL is congruent to NP. So we're also going to say that NP is also going to equal 2.1 meters. We can do the same as well with the angle measure. They give us an angle measure of N as, let me try again, as N as 50 degrees. So we want to figure out what's the other angle in our yellow triangle that matches that. Well, we know angle N is going to match to angle K, kind of like my helpful rule. What I was saying above was each of these letters is going to match exactly to the other. So we know that angle K is also going to be congruent to angle N. So that means because the measure of angle K is equal to the measure of angle N, then we know the measure of angle K is going to equal 50 degrees. Remember, there is a difference between saying congruent as well as saying equal. Remember, in our couple last sections, we talked about how saying in measure of an angle, we're always going to use equal signs because that's when we know certain degrees. So, looking at that example, we can kind of break apart and see which pieces match each other. Let's go ahead and try to go down to the try these A section. Now, before we look at the try these A section, let's look in the margin right now at another one of the math tips that they gave us. As a nice reminder, 2 line segments are congruent if and only if they have the same length. Remember, same size, same shape, right? And line segments, ironically, they are the same shape. It's a line segment, so they have to be the same size. So 2 angles are congruent if and only if they have the same measure. That goes with angles as well, right? Same size, same shape, right? Angles are, always going to be the same shape because they're angles, but remember, they have to be that kind of same size. That resorts back to their measure. Let's look at the try these A now. In the figure, triangle RST is congruent to triangle XYZ. Remember what I was telling you about the order of the letters. Keep that in mind when we're saying 2 triangles are congruent. What they want us to do is find each of the following if possible. So I'm going to give you an opportunity right now to pause the video and try A, B, C, D on your own with this picture. Go ahead. So for me, what I always like to do is I always like to kind of mark which points go with which points, right? So I know that I have point R is going to match up with point X. So if I know the measure of angle X, right, I'm going to be able to find the measure of angle R. So again, we know that these are going to be equal, so it's going to be equal to measure of angle, let me try that again, R. But is there a way in the picture that I know? Do I know what either of those angle measures are? I don't. So we're going to say here it's not possible to find out what the measure is since I don't know the measure of angle R or the measure of angle X. Let's keep moving on. So let's look at point T, or really angle T. Oops, sorry, I meant S. Let me try that again. Angle S. So I'm going to see which one that matches up to. That's going to match up to Y. Remember what I said, the order of our points given in our picture, that's why they kind of match up. That's why I matched up R with X. I'm now doing S with Y. So I know that one of the questions, A, B, C, D, it doesn't ask for the measure of angle S or angle Y, but it's still good for me. I like to match them up to each other. And then last but not least, let's match up angle T with angle Z. Again, I like to color coordinate. There is a question that says, what's the measure of angle T? Well, we know it's going to be equal to the measure of angle Z, and the measure of angle C is 47 degrees, so voila, we actually do know that's going to be 47 degrees. Now what we can do is we can use maybe some different colors to figure out what the different side lengths are going to be. So remember, order does matter here. So let's say I wanted to go from point R to S. I wanted to go from pink to blue. I would have to see what matches up on my other picture that goes from pink to blue. That's going to be XY. So we know that line segment RS is going to be matching to XY. Looking at the options that we have left, we see that's not one of those choices. So let's go ahead and move on to our next section. So let's do, let's go from our blue point to our yellow point. So on our first triangle, it's going to be S to T. That's going to match up to Y to Z. So we have that right here. Y to Z is going to be the same as S to T. So we know that's going to be 15 centimeters. All right, last but not least, let's look at measuring from our pink to our yellow point. That's going to be R to T, and that's going to match from X to Z. So what that means is XZ is going to be the same measure as RT. So even though we don't have necessarily the measures and we can say not possible, it's still good to look at these different relationships that we have. All right, hopefully you built up a little bit of confidence from that specific problem. So what we're going to go ahead and do is we're going to start to look at part E, which kind of built off of what we did initially, but it's kind of a problem of its own. So it says both triangle JKL and triangle MNP are equilateral triangles in which the measure of each angle is 60 degrees. So what we're probably going to do, and what would be good, is to draw triangle JKL. So I'm going to go ahead and draw that equilateral triangle, meaning that all three sides are going to be the same, right? They're all going to be equal to each other, and the angles will too. So let's label JKL in each of the corners, and I'm going to go ahead and label each of the sides showing that they are congruent to each other. Let's go ahead and draw the next triangle. I'm going to draw a triangle MNP, so let's label it in that same order that we did before with JKL, so MNP. And I don't necessarily know if all three sides of our first triangle will match the second triangle. All I know is that each angle is 60 degrees. So what I'm going to do is I'm going to label M and P, all three sides of that triangle, with 2 tick marks. So I know that they're congruent within each other. But I don't necessarily know if it's congruent to all the sides of JKL. All right, so something else that we know about both of these triangles is that each of their angle measures is 60 degrees. So I'm going to go ahead and label that in each of the triangles and also use the congruence tick marks to show that each one of those is 60 degrees. So the question says, can you tell whether or not triangle JKL is congruent to triangle MNP? And it says explain. Well, let's think about this. Equilateral triangles, they have the same sides within each other and they have the same angles within each other. But do we know if all equilateral triangles are the same? Think about it when you've seen it in the real world. Are all equilateral triangles the same? Could we have some bigger? Could we have some smaller? Yeah, we could. Let's say I took one of these triangles and I shrunk it down, right? Just like this drawing. Each of the angles will actually still say 60 degrees. It will. And each of the sides will still be congruent to each other, but it's not going to be congruent to the one of the other two triangles. So it's good to draw a picture to show this. So thinking about this, we know that, well, it doesn't necessarily mean that triangle JKL is going to be congruent to triangle MNP. We know all equilateral triangles have the same angle measure, but they can have different side measures. So no, we really can't show that they are congruent. So here's what we should do. We should go ahead and answer this problem. All right, can we tell whether they're congruent or not? We said no, we cannot. And remember, our reason is going to be all equilateral triangles have the same angle measure, but can have different side measures. Now, something else to keep in mind is remember what congruent really means. That congruent symbol, right? It means same size and shape. Whereas here, we know all of them are the same shape, but guess what? They are not the same size. All right, let's go on to the next page. We are going to look at our last few problems. So let's zoom in to numbers 4 through 7. So number 4 says, if two triangles are congruent, can you conclude that they have the same perimeter? Why or why not? So I want you to go ahead and think about how you would answer this question. And then let's go ahead and think about this and what makes sense and answer in the margin. Think about what congruent triangles mean. They have the same size and shape, right? So that means congruent triangles have the same side measures with the same, the same lengths. This means that the sum of their side lengths will be the same. So we're going to say yes. And I'm going to use some symbols to help me out. We're going to say congruent triangles have the same size and shape, which means they have the same side lengths. And then I'm going to say therefore, which sometimes we actually use this fun little triangle symbol, 3 dots of a triangle, to mean the word therefore in mathematics. So I'm going to say therefore, the sum of their side lengths will be the same. So cool, you just learned a new little symbol, so that means, let's try a different color. So let's use that as therefore. So if you ever see where you have 3 dots, that always means therefore. Nice job. All right, so that was number 4. Let's go ahead and read number 5. 5 says, is it possible to draw 2 congruent triangles So that one triangle is an acute triangle and one triangle is a right triangle. Why or why not? Well, wait a minute. Congruent triangles have the same angle measures. So an acute triangle has all acute angles, and a right triangle has only one right angle. So no, it wouldn't be possible to do this. So let's go ahead and write down number 5 in the margin. We're going to say, no, it's not possible. No. We're going to say congruent triangles have the same angle measures, right? So an acute triangle has all acute angles, and a right triangle has a right angle. Yeah, that wouldn't necessarily make sense. Book's trying to trick us again, right? This is check your understanding, so it gets us to really critically think about some of these problems we've come up with. Let's go ahead and scoot on down. All right, we only got 2 more, 6 and 7. So we're going to be using this visual to help answer questions 6 and 7. So 6 says, rectangle ABCD is divided into 2 congruent right triangles by diagonal AC. It wants us to fill in the blanks to show the congruent sides and angles. So I want you to go ahead, pause the video right here. I want you to go ahead, test your knowledge, and see if you can complete number 6, ABCD. All right, here's what I did. Since some of the same points are being used within our 2 congruent triangles, I decided to mark their side lengths with certain colors, and then that way I can show you with arrows how we can read them off. So we know that we have segment AB. We have to say it's congruent to segment CD, and we have to make sure we have that order correct. When we're looking at segment BC, we have to say that's congruent to DA. Now, when we're looking at angle BAC, we're looking at this angle. We have to match it up and make sure it's congruent, right, to this angle. So I read that off as DCA because I read off whatever is at that right angle first. And then last but not least, we're looking at angle ACB, which is this angle. I'm going to label it with a different symbol so that way I don't get it confused with the other angle. So when I'm labeling that ACB, I label the right angle last. So for us, when we're labeling it, we have to label it CAD. So D is going to be labeled last. All right, so it's a little bit easier to visualize that with a picture, but now I want you to try number 7, where you don't have a picture, and the only given information that we have is that triangle PQR is congruent to triangle GHJ. So let's see if you can fill in the missing information here and say which line segments and angles are congruent. All right, go ahead and check your answers with mine. Make sure they're correct. Remember, we don't necessarily have to have a picture for this, but we can match up the given information with what they gave us. All right, so I know your teacher is probably going to be assigning you homework tonight. For Miss Graham's class, what you're going to be doing is your homework for tonight. Let's get a pen for that, not a highlighter. So Miss Graham's homework for tonight is going to be page 146, what we're on, and it's going to be numbers 8 through 11. So it's going to be this section right here. Again, if you're not in Miss Graham's math class, go ahead and check with your teacher for what the homework is tonight. Happy mathing!